Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Iqbal Firdaus bin Zulkifli. My metric number is AD1900074. For introduction of this project, we will look at the two-dimensional motion of a projectile in sports, which is basketball. The implication that must be taken into account is the object original velocity and the object's final velocity, after which it travels only under the influence of gravity, just as tossing a ball. Projectile motion can look confusing. Projectile motion in the vertical direction can be broken up into rapid motion, or in the horizontal position. It can be also regarded as a free fall and continuous velocity motion. The objective of this project is to understand the idea of the motion of projectile. Next, to calculate the speed of horizontal shot of a basketball. Next, to calculate the time of basketball to reach the net. Next, to identify the projection angle that generate at the maximum rate. Lastly is using a set of angles to identify the average ball projection.
So this is the description and methodology for this project. Projectile motion. The definition of projectile motion is the motion of an object which is already thrown or projected into the air, subjected only to the acceleration of gravity. The object is called a projectile and its trajectory is called its direction. The projectile definition and formula are important for assessing the value of this project. Another definition of the projectile motion is a form of motion encountered by an object or particle that is thrown near the surface of the earth and only travels under the action of gravity along a curved path. In particular case, the effects of air resistance are assumed to be negligible. Velocity in the horizontal direction is constant. The vertical motion is the motion of a particle during its free fall. So the acceleration is constant, which is equals to the gravitational acceleration 9.81 meter per second squared. Galileo has shown that this curved path to be a parabola, but it may also be a straight line in a special case when it is thrown directly upward. So below is the definition of parabolic path of motion according to Galileo, and the right one is the example of the parabolic path of motion, which is applied in the netball and the basketball. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about our analysis and calculation for our group project. First one, we use three equations from kinematic equation for calculating the velocity and the magnitude and also the direction. As we can see in this picture, the height of the net is constant, which is 3 meter, and the distance from the net to the person is fixed, which is 10 meter. Okay, the first step in our calculation is we take the distance from the net to the throwing point, which is fixed, it's 10 meter, and the height of the net, which is 3 meter fixed. Then we substitute into the first equation to obtain the velocity of y-axis, which is 5.32 meter per second. Then we substitute the value of velocity in y-axis to get the value of time, which is 0.54. The next thing is we calculate the value for x-axis, which is we substitute the value of time in the formula and obtain the velocity of y-axis. The last thing is we need to find the magnitude and the direction. First, we use this formula, which is Pythagoras theorem formula. We substitute the velocity x and velocity y into the equation and solve it. Then we find the angle of the projectile. which is 16.31 degree. After we calculate all the calculation need for all individual, we obtain the result and we put it in this table. This table show all the result from different individual.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aida Muzira binti Muhammad Murad. My metric number is AD180145, and today I would like to explain the discussion for this project. So for a better understanding, the kinematics we took for the analysis are the case of free throw. So in modern basketball, the procedure of making a basic mechanism of free throws can be carried out is the one with one hand. So this can be structured by these stages or these moments. First is preparatory phase, and second is throw itself, and third is final position. So due to the realization of this model, we wish to highlight the angle of release and initial velocity for those the throw is validated. So we can conclude that the best throw is not passing by the middle of the rim, but closer to the back side of the rim. Next, as the player is taller, the throw is much easier. In terms of the initial speed and release angle, the margin of error is greater than the shorter players. Next, as you are smaller, the release angle is bigger. This can confirm by the height from which release the ball. A shorter player has a wider area of coverage than a top player. From the same initial speed, release, and the same distance, there are two different angles, which is a minimum and a maximum angle. For that, disposal is valid. For each distance and player's height, there are initial velocity and optimal release angle for that throw to be valid. Lastly, the validity of this model was verified only on athletes group for those who was made the film. The obtained dates were compared with the found dates by the analysis of the similar studies. So in the analyzed studies, the release angle varies between 20 degrees and 30 degrees. That confirms the dates of our model. So thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh, and I hope you guys in good. Okay, my name is Muhammad Narasmai Arif bin Salihuddin. Okay, I'm from the FKMP faculty. Today I would like to conclude about the conclusion and finalize about our project. Okay, from the experiment that has been done in this project, we have identified that if the person of the basketball player have the grade of his height, then the time taken for the ball to reach the goal will be less, although the velocity of the ball for the x-axis will be increased. However, for the y-axis it will be decreased, and the angle direction of the ball that have been thrown will be decreased. For example, from the table 1 in analysis, the player with the height of 1.56 meter will have less velocity for the x-axis after he throws the ball, which is 18.18 meter per second, and the time taken for the ball to reach the goal will be 0.54 seconds. Compared to the player with the height of 1.73 meter, they will have more velocity, and the time taken for the ball to reach the goal will be less, which is 0.51 seconds. Okay. Objectives that have been achieved through the collection data for this project is we had understand the idea of the motion of projectiles. We also understand all the concept of motion and able to implement the formula of projectile motion in the engineering problem. We also managed to calculate the speed of the horizontal shot of the ball and time for the ball to reach the goal. We also identified the projection angle and generates the maximum rate an average of ball projection by using set of angles. By the end of this project, we got a lot of knowledge and skills that cannot be obtained in the class. It can be found by making some by implementing the theory that we have learned in the class. uh, we can solve the problem regarding to the project. Overall, this project has given us the platform to experience hands-on skills on the tasks that have been given by our lecture and to understand more about the projectile motion. Okay, that's all from me. Thank you everyone. Bye.